Hello everyone, this is Nandini Joshi from MTech IT 2K20 batch of IIPS DAVV Indore. In this video, we will be discussing the third internal question paper of the subject Analysis and Design of Algorithms. This is also a multiple choice question based paper which consists of 40 questions which we are needed to answer. So we will start the questions. The question number 1 is in Strasson's matrix multiplication, the number of multiplications needed to multiply 2 by 2 matrices is, we are given the options 4, 6, 8 and 10. As we know that Strasson's matrix multiplication is a type of problem which uses divide and conquer strategy or divide and conquer approach. So the number of multiplications needed is 6. So the correct option here is option B, that is 6. Question 2. Huffman coding is a type of lossless compression algorithm. Here the correct answer is option A, as this type of compression algorithm is used to compress the byte or the size of any type of file code without losing any data. In question number 3, in Kruskal's algorithm, what is the time complexity for sorting the edges of the graph? So for sorting the edges of the graph, Kruskal's algorithm requires different steps, and different steps have different time complexities. So one of the step in Kruskal's algorithm is the first step, that is sorting the edges of the graph in increasing order. After that we will start making the graph with the least weight of the edge. So for sorting the edges of the graph, the time complexity required is big O of n log n, that is option B, order of n log n. As we know that all sorting algorithms have a time complexity of order of n log n. So sorting the edges in increasing order or in ascending order will require a time of n log n. Question 4. In Prim's algorithm, what is the time complexity for finding the minimum weight edge from a vertex? The correct answer for this question is option A, order of n, that is big O of n. Question number 5. Depth first search can be used to find the longest path between two nodes in a graph. Depth first search is a technique of traversal of a tree which is used to find the longest path between two nodes in a graph. So the correct option is option B. Question number 6. Breadth first search. Breadth first search can be used to find the shortest path between two nodes. It is also a type of traversal technique or tree traversal technique, but it is different from depth first search as it finds the shortest path between two nodes, while the depth first search finds the longest path between two nodes in a graph. So for question number 6, the correct option is option A. Question number 7. Dynamic programming can be used to solve problems that exhibit. Here among the 4 options, the correct option is option A, that is optimal substructure and overlapping subproblems. Question number 8. The matrix chain multiplication problem can be solved using. So we know that matrix chain multiplication is a type of dynamic programming problem, as it uses dynamic programming approach for finding the solution by finding the recursive solution first and then optimizing it to find the final solution. So here for question number 8, the correct option is option A. Question number 9. The longest common subsequence problem can be solved using. So here also the correct option is option A, that is dynamic programming approach. The LCS problem or the longest common subsequence problem can also be solved using the dynamic programming approach. Question number 10. In Strasson's algorithm, the matrices to be multiplied are divided into. So, in Strasson's algorithm, the matrices that need to be multiplied are divided into two equal parts. So, here the correct option is option B, two equal parts. Question 11. The running time of Strasson's algorithm is, so the running time, that is the time complexity which it requires for the Strasson's matrix multiplication, is option C, that is big O of n to the power 2.81. See, we calculate the time complexity for Strasson's algorithm as we have learned in the video lecture for first internal question paper, in which we have used Master's theorem to find the time complexity for Strasson's algorithm using its recurrence relation. So the Master's theorem can easily find the time complexity for this recurrence relation, and it evaluates to be n to the power 2.81. So the final answer for question 11 is option C, 2 big O of n to the power 2.81. Question number 12. Huffman codes are prefix codes, which means that, so Huffman codes are prefix code, which means that no code is a prefix of any other code. Here the correct option is A only, as we can see that no code is a prefix of any other code. That is, no code depends on any other part of code. All codes are independent of each other. So here the correct option is option A only. The rest options are incorrect. Question 13th. The minimum number bits required to represent the symbols in a set using a Huffman code is less than the number of symbols. As we know that the minimum number of bits required to represent the symbols in a set using Huffman code is always less than the number of symbols. We can be given a symbols that can be equal to 100 or 1000 or much more than that, but the number of bits to required any symbol or a single symbol can maximum reach up to 4 to 5 bits. So the number of bits are always less than the number of symbols. So the correct answer for question number 13 is option D. Question 14th. What is the time complexity of the standard matrix multiplication algorithm? So the standard matrix multiplication algorithm takes up to n cube time. So its correct option is option D, order of n cube or n to the power 3. Question 15th. In Strasson's algorithm, what is the base case for the recursive algorithm? The base case for the recursive algorithm in the Strasson's algorithm is symbols with higher priority. Sorry for my mistake. Here the correct answer is given below the question only, which is option B, when the matrices are 2 by 2. So the correct option for this question is when the matrices are 2 by 2. Question 16. The Huffman code assigns shorter codes to. The Huffman code always assigns shorter codes to symbols with high priority. The symbols which occur the most in the sequence of the code or in the whole length of file, with the symbols which have appeared the most or which have higher frequencies are given or are assigned shorter codes, so that the number of bits can be balanced out. So here the correct answer for question number 16th is symbols with higher priority. Question 17th. In Kruskal's algorithm, how many times are the edges of the graph sorted? So for Kruskal's algorithm, the first step which is needed is to sort the edges of the graph in increasing order, and after that we take the arranged edges of the graph and start building a minimum spanning tree. So the sorting is done only once. All the unsorted edges are sorted in increasing order only once at the start of the algorithm. So here the correct answer is option A, once. Question number 18th. Prim's algorithm can be used to find the minimum spanning tree of. Here the correct answer is option A, undirected graphs. So the Prim's algorithm can be used to find the minimum spanning tree of undirected graphs, as the Prim's algorithm always creates a connected graph from the tree, or from it always creates a connected tree which doesn't have any loops. But in Kruskal's algorithm, a tree is formed but with separate and distinct edges. Question 19th. The time complexity of BFS, or the breadth first search algorithm is. So the time complexity for breadth first search algorithm is big O, or order of n. So the correct option here is option A. Question 20. The time complexity of depth first search is. Here also the same time complexity as taken by the breadth first search. So the correct option in this question is also option A, that is order of n. Question 21. What is the time complexity of the dynamic programming approach for solving the longest common subsequence problem? The longest common subsequence problem is sorted or is solved using the dynamic programming approach, and it uses a time complexity of n square. So here for question number 21, the correct answer is option B, big O of n to the power 2. Question number 22. In matrix chain multiplication problem, the number of matrices to be multiplied is. Here the correct answer is option A, given as an input to the algorithm. The number of matrices which need to be multiplied or which need to be parenthesized in a correct order are always given as an input to the algorithm, and the main objective of the algorithm is to apply parenthesis to the whole chain or the sequence of matrices which are given as input. So the correct option is option A. Question number 23. What is the time complexity of the dynamic programming approach for solving the matrix chain multiplication problem? The matrix chain multiplication problem requires a time of order of n cube. That is, here the correct option is option D, big O of n cube, or n to the power 3. Question number 24. Which of the following algorithms uses a greedy approach? Using a greedy approach means that finding the minimum weight or minimum cost, or using the or finding the best optimal solution at the present stage, at the current stage, and then moving forward with the required solution. So in this question, in the given algorithms, Kruskal's algorithm uses a greedy approach, as it always searches or tries to find for a minimum weighted edge, and uses it to form the minimum spanning tree. So the correct option is option A. Question number 25. The longest common subsequence problem can be used to solve. So the longest common subsequence problem can be used to solve DNA sequencing problem. Here the correct option is option B. Question number 26. The running time of Strassen's algorithm is faster than the standard matrix multiplication algorithm for matrices of size. Here the correct option is 4 by 4, that is option D. Question number 27. If the Huffman code, in the Huffman code, the average length of a code word is. The average length of a code word is always less than the number of symbols. So here the correct option is option B, less than the number of symbols. The length of a code, or the byte allotted to a single code, is always less than the number of symbols. Question number 28. What is the time complexity of the dynamic programming approach to solve the matrix chain multiplication problem? So here the correct option is option B, order of n cube. Question number 29. What is the maximum number of sub-problems that need to be solved in the dynamic programming approach for the matrix chain multiplication problem for n matrices? So the number of sub-problems which are required, the number of small problems which we have divided and we need to solve in the matrix chain multiplication problem for n number of matrices is n square. That is, option C is the correct option, n square. Question number 30. In the dynamic programming approach to solve the longest common subsequence problem, what is the recurrence relation used to calculate the length of the LCS? That is, what is the recurrence relation used to find the length of the longest common subsequence, which is the final solution of our problem. So here the correct option is option B. Option B states LCS of ij equals to max of LCS I minus 1 comma j and LCS of I comma j minus 1 if the condition here states x of I not equals to y of j. So let me specify clearly that here x and y are the length of the two that are the length of two sequences which have been given to us as input in the algorithm, and we have to find the longest common subsequence which is present in f, in x as well as in y. So if the condition is true, that is x of I not equals to y of j, then the LCS of ij, here LCS or the least longest common subsequence is a method or a function which takes I and j as input, and we will be finding the maximum of I minus j, that is the previous column, and I minus 1 of j, that is the previous column and the same row, and I of j minus 1, that is the previous row and the same column. So we will be finding the max of these both elements, and that will be the final length of the longest common subsequence. That is the final solution of our problem. Question number 31. In the dynamic programming approach to solve the longest common subsequence problem, what is the time complexity to print the LCS? Here the correct option is, that is the time complexity to print the LCS is big O of n, that is order of n. Here the correct option is option A. Question 32. What is the time complexity of the dynamic programming approach to solve the matrix chain multiplication problem for a given sequence of n matrices? So for a given sequence of n matrices, the time complexity in the matrix chain multiplication problem is, we have discussed this question previously also. So we know that the correct answer for this question is n cube, that is order of n to the power 3. So the correct option here is option B. Question 33. What is the time complexity of the dynamic programming approach to solve the matrix multiplication for a given sequence of n matrices? Up to here the question still remains similar, but the word memoization makes it different. So in this question we have been asked about the process where we use the memoization technique to solve the matrix chain multiplication problem. So this will take different amount of time. So the final answer for this question is 2 to the power n, that is it uses logarithmic time complexity to find the solution. Question 34. Which of the following algorithms can be used to solve the longest common subsequence problem? So the longest common subsequence problem can be used uses the dynamic programming approach. So here the correct option is option D. Question number 35. Which of the following algorithms can be used to solve the matrix chain multiplication problem? So the matrix chain multiplication problem also uses the dynamic programming approach to find the solution by finding a recursive solution first and then optimizing that recursive solution. Question number 36. In the dynamic programming approach to solve the matrix chain multiplication problem, what is the minimum number of scalar multiplications required to multiply n matrices? The minimum number of scalar multiplications which are required to multiply n matrices. To multiply any two matrices, the minimum number of scalar multiplications required are m into n into r, where m into n is, where m by n is the order of first matrice and n by r is the order of second matrice. So the number of scalar multiplications required for these two matrices are m by n by r, that is m into n into r. So for n matrices, this will be m of 0 of 0 and n minus 1, that is for m matrice. For m matrice, we will be taking the zeroth row and n minus 1th column, the value which is present in the m array. So here the correct option is option B. Question number 37. In the dynamic programming approach to solve the matrix chain multiplication problem, what is the minimum number of scalar multiplications required to multiply a chain of length n minus 1? For this question, the correct answer is option B, that is m of 0 and n minus 1. Here also the same answer as previous one, that is minimum number of scalar multiplications required. So the correct option is option B. Question number 38. Which of the following is not a sub-problem of the dynamic programming approach to solve the longest common subsequence problem? So the longest common subsequence problem does not consist the sub-problem which is LCS of I plus 1 j plus 1. That is, for solving the LCS, when we construct a matrice or the table using the values for the length of LCS, we do not ever take the value which is present in the next row and the next column. So we don't go diagonally downwards, we always move towards the right. So here the correct option for this question is option D, LCS of I plus 1 j plus 1. Question number 39. The dynamic programming approach to solve the longest common subsequence problem has a time complexity of the correct answer is big O of n square. The LCS problem or the longest common subsequence problem requires a time complexity of big O of n to the power 2, that is n square. Question 40. What is the difference between Prim's algorithm and Kruskal's algorithm for finding the minimum spanning tree of a graph? We have discussed this point earlier also when we were discussing Kruskal's and Prim's algorithms time complexity, that the difference between both of these algorithms are used to find the minimum spanning tree of a graph, but the only difference between both of these algorithms is all of the given reasons. So the first reason can be Prim's algorithm starts with an arbitrary node and adds the shortest edge from the set of available edges, while Kruskal's algorithm starts with the shortest edge and adds edges in increasing order of their weight. As we know that in Kruskal's algorithm we arrange all the edges in the increasing order or in the ascending order of their weights, and we add edges one by one. But in Prim's algorithm, we take any arbitrary node as our starting node and start to visit each and every edge which is connected to it and select the minimum edge present in the given set of edges. Option B is Prim's algorithm uses a priority queue to select the next edge to add to the tree, while Kruskal's algorithm uses a disjoint set data structure to maintain the set of connected components. All of these differences relate to the same difference only, that from where we choose the minimum weighted edge. In Kruskal's algorithm, our selection criteria for checking for minimum weighted edge is different, and in Prim's algorithm it is different. Option C, Prim's algorithm always produces a connected tree, while Kruskal's algorithm may produce a forest of disconnected trees. See, it is required to visit each and every node for once, and for that reason Kruskal's algorithm and Prim's algorithm both creates a minimum spanning tree with all the given nodes from the undirected graph. It contains all the nodes, but some of the edges are deleted or some of the edges are removed, so that to make it a minimum spanning tree. So Prim's algorithm always creates a connected tree, and the Kruskal's algorithm may visit any edge as we have stated all the edges in the increasing order of their weights. So here for this question the correct answer is all of the above, that is all the given reasons can be considered as the difference between both of these algorithms. So we have answered all the questions for this question paper, and this concludes our all the internal assignment or all the 3 internal question papers. Now in the next video lecture we will be discussing the end sem or the final exam question paper and reviewing it. So thank you everyone.